How do you currently deploy your infrastructure? Do you manually click around in AWS console to launch servers, databases, and networking? With IAC tool, you can define your entire infrastructure as a code, making it automated, scalable, and consistent. So in simple terms, Terraform, which is an IAC tool, lets you write your infrastructure as code and deploy it anywhere. In this video, we'll break down Terraform step by step so that by the end, you will start using it for your own cloud projects. Let's get started. So in traditional environments, setting up infrastructure meant logging into cloud providers like AWS, Azure, or GCP, and manually creating resources like servers and database. So this can consume time, lead to human error, inconsistent environments, and limited scalability. Now, how does IAC help out? So in simple terms, instead of clicking around in a web console, you write your code to describe what your infrastructure should look like. Some of the key benefits of IAC include automation. So no more repetitive manual tasks. You just run your script and your infrastructure is set up. 2 is consistency. Every deployment is identical, whether you're deploying in development, staging, or production. 3 is version control. Just like software code, infrastructure code can be versioned, rolled back, or reviewed in Git. 4 is scalability. So you can automatically scale your resources based on demand. You can spin up one server or hundreds of servers just with a single line of code. Now 5 is documentation. Your code serves as documentation, so anyone can understand your infrastructure just by reading the code. Terraform is one of the most powerful and widely used IAC tools today. It was created by HashiCorp and it allows you to define, provision, and manage your cloud infrastructure efficiently using a simple and powerful configuration language called HCL. So with Terraform, you just write a simple configuration file that describes your infrastructure, and Terraform automates everything. If you need to make changes, just update the configuration file and reapply. Terraform ensures that the changes happen safely. It also maintains a state file which keeps track of what is deployed, preventing accidental changes. So basically, Terraform brings automation and efficiency to your infrastructure in software development. So Terraform has become a standard in the DevOps and cloud world because of 4 reasons. 1, it is cloud agnostic. So Terraform supports multiple cloud providers such as AWS, Azure, GCP, and platforms like Kubernetes. 2, declarative approach. So Terraform describes the desired end state of your infrastructure instead of executing step-by-step commands. 3 is scalable and repeatable. Terraform enables you to scale infrastructure effortlessly and reuse configurations across different environments. 4 is Terraform state management. So Terraform maintains a state file which acts as a single source of truth for your infrastructure. So this means that Terraform knows exactly what is deployed and can detect and apply changes safely. Now that we understand the basis of Terraform, let's break down 8 core building blocks and how they work together. 1 is provider block. So a provider is what allows Terraform to interact with different platforms and services. Providers act as a plugins that allow Terraform to manage resources in AWS, Azure, GCP, Kubernetes. Now the provider block is declared like this. You have the provider link, then inside that block, you can specify configuration options. Let's say, for instance, this block tells Terraform that we want to work with AWS resources in the US East 1 region. 2 is resource block. So a resource block in Terraform is anything it creates, like servers, databases, and networking components. So the syntax follows the structure: the resource type, resource name. Then inside the block, you can specify configuration arguments. Now, let's say, for instance, this block tells Terraform to create an EC2 instance with the specified arguments. 3 is variable block. So variables in Terraform make your configurations dynamic and reusable. Instead of hard coding values like instance types, region's name, or credentials, you can define variables and use them throughout your Terraform files. So this helps to improve scalability, flexibility, and maintain your infrastructure code. So the basic syntax follows the structure. variable, variable name. Then inside the block, we have things like type, which is a data type such as string, number, list, map, etc. Default, which is an optional value. Then description, which explains the variable. We also have the output block in Terraform. So this allows you to display important information after infrastructure deployments. It helps you to retrieve values like your public IP of an EC2 instance. In terms of an output block follows the structure. Output, output name, value, we specify the value to be returned. Now let's take for instance, this block is using Terraform to display the instance IP address after provisioning the instance. We also have data block. So the data block in Terraform allows you to fetch existing resources from a provider without creating a new one. It helps when you need to query existing resources, retrieve dynamic values, or reference shared infrastructure. Now, when working with Terraform, the process follows three main steps. One is initialize. So the Terraform init command initializes a Terraform working directory, downloads the required Terraform providers, configures the backend for state storage, verifies and set up modules if used. 2 is plan. The Terraform plan command previews the changes Terraform will make before applying them, shows what Terraform will add, change or destroy, helps avoid mistakes before making actual changes, but does not modify the infrastructure yet. So the Terraform apply command executes the plan and provision the resources. It will create, update or delete resources as needed. Now, if you found this video helpful, like, subscribe and comment. Until next time, keep building.